Hello, grade 9 students. Welcome back to another learning episode of Quarter 3. Once again, this is Teacher Shermay for School on Air Science 9, and we are now in week 7. And this week's lesson is about climate change. And why should we care about climate change? We care about climate change because it impacts our life, our health, our environment, and even in the development of pests and diseases. Scientists call climate change as the crisis of our time. World leaders are meeting in Madrid to talk about climate crisis and how to slow it down. Now, let's check out first our objectives. Number 1, describe climate change. Number 2, describe how human activities contribute to the climate change. And third, describe how climate change is lessened or reduced. So, grade 9 students, are you ready? So, for us to understand and broaden our perspective on climate change, let us hear lecture on climate change.
In 2018, I got to walk across the surface of a receding glacier in Iceland. From where I stood, I could see a patch of snow and ice off in the distance, the last remnants of another glacier that had since melted away. That ice-speckled area was all that remained of 800-year-old Ökjökull, or Oak Glacier, which was officially declared dead in 2014 by Icelandic geologist Odur Sigurdsson. It once spanned an area as large as 38 square kilometers. In 2019, the loss of Ökjökull was commemorated with a plaque on the site of the former glacier. It's the first monument dedicated to a glacier lost to human-induced global warming. Looking after our planet and all its dynamic ecosystems and landscapes, including glaciers, is everyone's job. We know rising temperatures are correlated with rising carbon dioxide in the atmosphere, and the amount of carbon dioxide generated by our day-to-day actions can have an effect on the other side of the world. But while individual actions matter, who is emitting carbon dioxide is highly unequal. About half of total US emissions in 2019 were direct emissions from corporations, coming from sources like power plants and oil and gas production facilities. So they also have responsibility to share the burden. Knowing who or what is emitting carbon dioxide is only part of understanding climate change. We also study who emissions affect and the geographical impacts of a warming planet. Climates are complex, so I don't have all the answers, but there's a lot we can learn. I'm Alize Carrere, and this is Crash Course Geography. Even with a problem as complicated as climate change, we can start with a picture. Like this picture of Muir Glacier in Alaska from 2004. Pictures and maps can show us where land masses, oceans, and geographical features are located, which is spatial information that we kind of take for granted. The Earth is dynamic, and we have to remember that both pictures and maps are really snapshots of a particular time. So if we compared this image to past ones of the same area, we'd see how it's changed, and we could explore why change is happening here. A photo taken in 1941 from the exact same spot as the recent photo shows an entirely different landscape. The glacier was much bigger. After looking at lots of old and new photographs, current glaciological surveys, and the geologic record, we know glaciers around the world in places like Alaska, the Swiss Alps, and Mount Kilimanjaro have shrunk dramatically. Muir Glacier is just one example. To get deeper into the why, we know that ice and snow melt faster as air temperatures get warmer. But glaciers also depend on how much precipitation they get each year. If less snow accumulates, glaciers lose more ice on their bottom edge than they can replace at the top. That precipitation comes from the hydrosphere, and its regional patterns can depend on temperature and wind patterns over distant oceans. So mountain landscapes have changed as climate patterns have changed, which ties back to the global energy budget and insulation and the beginning of the Earth. It's a complicated problem. The terms climate change and global warming are often used interchangeably. But even though these phenomena are closely related, there is a difference between them. Climate change is the change in average weather patterns in a region over a long period of time. These changes can be natural or anthropogenic, meaning human-induced. And when I say long, I mean each climate period can last for several decades or longer. For example, there was a little ice age that happened from 1300 to 1850 CE. Mountain glaciers expanded worldwide, and mean annual temperatures dropped by 0.6 degrees Celsius in the northern hemisphere. That's a 550-year climate pattern, which then changed to a different one. On the other hand, global warming is the increase in the average surface temperature of our planet. In our current period of global warming, there's been a well-documented rise of average temperatures around the globe since the Industrial Revolution in the 1700s and 1800s. So when scientists or leaders talk about global warming, they're almost exclusively referring to this recent warming, which comes from human activities that increase greenhouse gas emissions like carbon dioxide, methane, and nitrous oxide. They trap solar energy, so more heat is held in the atmosphere. That additional energy is changing not only the average temperature, but also climate processes within the atmosphere and oceans. These include more extreme storms, heat waves, droughts, changing regional temperature and precipitation patterns that cause vegetation zones to shift and glaciers to melt, which results in sea level rise and changing coastlines. Essentially, when the planet gets warmer, climates change. We know the Earth has had many different climates thanks to paleoclimatologists, who study past climates through proxy data, or data that provides clues about the past. Comparing multiple proxies gives us a more complete picture of what happened and helps us anticipate the changes we need to prepare for. For example, they use tree rings that show dry and wet years, fossilized bugs that tell us about moisture and temperature levels of bygone ecosystems, or deep-sea sedimentary records that reveal the ocean's past. Like the deep-sea sedimentary record shows that the Earth overall had one of two extreme climates, and glaciers advanced and retreated across the Earth at least 28 times during the past 2.6 million years. We can see that when glaciers advance and the climate is colder, glaciation occurs and sea levels drop. And when the climate is warmer, glaciers retreat and sea levels rise, ushering in an interglacial period, which is what we're in right now. One of the most useful kinds of proxy data for atmospheric conditions and how climates changed year to year are ice core data. From ice, we can extract the chemical composition of past atmospheres. Using special drills, paleoclimatologists have extracted long tubes of ice from ice sheets and alpine glaciers all over the world, and estimated climates going back at least 400,000 years. Let's go to the thought bubble. On the top is fresh snow that fell this year and the year before and the year before that. Underneath is the snow that fell when Marco Polo traveled the Silk Road, and beneath that, when the Buddha gained enlightenment. And the deepest layers were laid down long before recorded history. The very bottom of ice sheets in places like Greenland and Antarctica have snow that fell before the beginning of the last ice age, 115,000 years ago or more. Just like snow on a sidewalk can get compressed by boots into sheets of slippery ice, the snow on ice sheets is compacted into huge solid masses. And buried in each layer of ice is evidence of past atmospheric conditions. Tiny air bubbles, which act like time capsules. Once an ice core is moved from the field to the lab, scientists use isotope dating to tell whether the carbon dioxide in those frozen bubbles was released from burning materials like wood or coal in the lithosphere, or if it was airborne during a nuclear explosion, or if it was part of the natural cycling of carbon. Paleoclimatologists have collected polar ice core samples and analyzed historical air bubbles from Greenland and Antarctica, tropical glaciers in the mountains of the Andes and Kenya, and mid-latitude glaciers in the Alps and Himalayas. When all these data are lined up, scientists can compare them with each other and see atmospheric trends, which in turn shows climate change over thousands of years. Analysis shows that it can take just a few decades to change from colder to warmer climate patterns. That might not sound fast, but when you're a 4.5 billion-year-old planet like the Earth, that's nothing. Thanks, Thought Bubble. By analyzing proxy data like bubbles in ice cores, we know the Earth's climate has changed significantly many times. As geographers, let's go deeper into why these drastic changes happen. Based on that proxy data, paleoclimatologists hypothesize that climates change because of any combination of several driving forces. First, past climates could have changed because of orbital causes, like changes in the shape of the Earth's orbit, its tilt on its axis, and the time of year when the sun is closest to the Earth. Like calculations by the mathematician Milutin Milankovitch show that lots of glacial cycles occur every million years. Second, volcanic activity can release enormous amounts of volcanic dust into the stratosphere. Strong winds spread that dust around the world, darken the skies, and reduce the amount of insolation that can reach the surface, which lowers temperatures. This is related to the albedo effect, or the amount of sunlight a surface reflects back into space. Volcanic dust and even the color of surfaces change Earth's albedo. White surfaces, like ice, reflect the sun's energy, creating a cooling effect. So when there's less ice, the opposite happens. Darker surfaces absorb sunlight and warm the surface of the Earth. Similarly, when something big like an asteroid strikes, it can cause an impact winter. Like volcanic activity, a big impact throws dust and debris into the air, blocking out insolation and lowering temperatures. Such an impact may have caused the extinction of the dinosaurs 65 million years ago. Another reason that climates change is when continents and oceans get rearranged. Like when the Isthmus of Panama formed, it broke the connection between the Atlantic and Pacific Oceans, which redirected ocean circulation and created the Gulf Stream. This changed how moisture and ocean currents moved around the globe, which, as we know, contributes to climate patterns. And finally, climates change when greenhouse gases in the atmosphere change. We know from ice core data that carbon dioxide levels in the atmosphere decreased when glaciers formed during ice ages and increased during interglacial periods. However, what's happening now is unlike anything in the past. We're in an interglacial period now, and glaciers are melting faster than ever before in the geologic record. Average annual global temperatures have risen between 0.3 degrees Celsius and 0.6 degrees Celsius, and sea level has risen between 10 and 25 centimeters during the past 100 years. And in 2016, global atmospheric carbon dioxide levels passed the 400 parts per million mark, which is higher than at any time in the past million years. More carbon dioxide increases the amount of heat trapped in the lower atmosphere, enhancing the natural greenhouse effect that makes life possible. So our climates are entering new patterns. If this upward trend in global temperatures was caused by natural processes alone, geographers would consider it natural climate change. But like I said, what's happening now is unlike anything we've ever seen on Earth. So scientists have used multiple lines of evidence like tree ring and ice core data, glacial retreat and sea level rise, isotope dating, changes in atmosphere, and changes in weather phenomena to study the climate. And they've concluded that there is a greater than 95% probability that human activities, like burning fossil fuels, industrialization, modern agriculture, and deforestation, have caused most of the Earth's warming since the mid-20th century. We are experiencing anthropogenic global warming. But not all areas will be affected equally by global warming and modern climate change. While materially rich countries are the main producers of greenhouse gas emissions, materially poorer countries will bear most of the impacts, like becoming climate refugees, people being forced to flee their homes for safer places. Thousands of low-lying islands and coastal cities face a threat of rising sea levels by the end of the 21st century, when sea levels are predicted to have risen 26 to 77 centimeters. That's pretty significant considering over half of the world's people live within 100 kilometers of a coastline. For example, located halfway between Australia and Hawaii, Kiribati has 33 atolls that sit less than 2 meters above sea level and average only a few hundred meters wide. The government of Kiribati is planning a two-phase migration with dignity and has purchased several thousand acres of land in Fiji as a potential resettlement location for its 102,000 residents. But migration with dignity isn't an option for all countries and communities. For some places, adaptation is the only option, like building seawalls or raising streets and homes. And for some, that will mean moving to higher elevations after the flooding without government support for the process. Flooding from sea level rise is just one of many changes that we can anticipate. Other places, for example, will experience drier conditions with the potential for droughts, heat waves, and wildfires. The current ways the Earth's climate is changing because of global warming will affect all of us as individuals. So it's our collective responsibility to pay attention and take action.
This is Earth, the planet in our solar system that we live on. However, our planet is not on a good path for continuing to sustain life. The Earth is facing the accelerating detrimental effect of climate change, also referred to as global warming. Well, what exactly is climate change? Climate change is defined as a long-term change in the Earth's overall temperature with massive and permanent ramifications. Climate scientists believe that this isn't caused naturally by the Earth, but by human activity. Earth's atmosphere consists of gases such as oxygen and nitrogen, and other gases known as greenhouse gases like carbon dioxide, nitrous oxide, and methane. Incoming light from the sun hits the Earth's surface. The Earth absorbs some of that energy, heating the surface of the planet. The rest of that energy gets reflected. Some of that energy goes back out into space, but greenhouse gases like carbon dioxide trap the energy and send it right back to the Earth's surface, heating it up even more. This is known as the greenhouse effect. Now, a little greenhouse effect is natural to the Earth and is a good thing to have, but a large greenhouse effect can be catastrophic, causing a lot of that energy to stay in our atmosphere and heat up the Earth at an accelerating rate. Some of the main human activity that emits greenhouse gases are fossil fuel burning, animals, agriculture, and deforestation, and waste and recycle pollution. Burning fossil fuels like coal, oil, and natural gas, as well as gasoline, are some of the largest pollutants of carbon emissions. Not only that, but when fossil fuels are burnt and their gases mix with heat, they create smog, a thick air pollutant that is highly toxic. For example, Beijing smog is so thick and heavy that you can't go outside without some form of surgical mask or breathing filter. The massive amounts of excrement produced by livestock farms emit toxic gases such as hydrogen sulfide, ammonia, and methane into the air. Methane is 23 times more effective at trapping heat than CO2, and roughly 80% of these emissions in the US come from animal waste. Over 56 billion animals are globally raised every year for food purposes. That's 8 times more than the human population, and 8 times as much waste adding emissions to our atmosphere. Land used for growing animal feed and raising animals for food used a staggering 30% of the Earth's landmass in 2006, and the food production industry has only increased since. 7 football fields worth of land is bulldozed every minute to create more room for farmed animals and the crops that feed them. Bulldozing land and deforestation not only emits greenhouse gases, but it gets rid of plants, trees, and forests, the things on our planet that actually absorb carbon dioxide. The more we deforest our Earth, the less carbon dioxide it can absorb from our atmosphere. Solid waste landfills are some of the largest pollutants of methane gas in the United States. The average person produces 4.3 pounds of trash per day. That's 1,569 pounds of trash per year for one person. With the 7+ billion people that live on the globe, that's 11.6 trillion pounds of trash dumped into landfills every year. But how do we know that our human activity is the cause of accelerated climate change and not the Earth's natural process? Our civilizations produced a devastating 40 billion tons of carbon dioxide last year, which equals 700 trillion cubic feet of CO2. That's a little more than 100 Mount Everests of CO2. It's enough CO2 to fill the entire Grand Canyon 5 times, or it's the equivalent of 19 million Empire State Buildings. The largest natural pollutant of the Earth are volcanoes. If we take the largest scientific estimate of carbon emissions produced by volcanoes every year, that's 500 million tons of volcanic CO2. But that's not even 2% of the nearly 40 billion tons of CO2 that our civilizations produced. Over the course of thousands of years, our climate goes through a natural climate cycle of carbon dioxide being absorbed and released into the atmosphere. But once the Industrial Revolution kicked in, burning fossil fuels became the necessity of manufacture and production plants, and the CO2 level shot up violently and have not slowed down since. The Earth has not seen this much carbon dioxide in its atmosphere for millions of years. Our planet with the greenhouse effect is like a bathtub being filled with more water than it can drain. Eventually, it will fill up with more than it can handle. But why should we care about global warming and climate increasing? The Earth's temperature has risen 1.5 degrees Fahrenheit over the past century and is projected to rise another 0.5 to 8.6 degrees Fahrenheit over the next 100 years. Animals and plant life are struggling to adapt to these conditions for survival. If even one species goes extinct, it can create a domino effect with the food chain. No living plants or animals means no living humans. Rising temperatures makes the Earth's oceans become warmer, which causes something known as ocean acidification, which rises the acid levels in the oceans from the carbon dioxide reacting with the salt water. Ocean acidification harms animal life and is what's causing the death of the Great Barrier Reef. This is a problem because about 1 billion people use ocean life as their main source of protein. Since the oceans are becoming warmer, the polar ice caps are melting, which has caused almost 65% of the polar ice caps to melt since 1979. The Earth loses on average 400 billion tons of ice each year. That's like a giant block of ice 4 miles long on each side, 64 cubic miles, that melts and is added to the ocean. The oceans fill with too much water, and the shores, like in Louisiana, can't hold all that water, and coastal regions get flooded and destroyed. Climate change also causes more frequent and intense natural disasters such as hurricanes, floods, tornadoes, heat waves, and droughts. So the question is, how do we stop this? Instead of burning fossil fuels, we need to convert to renewable energy such as solar and wind power, which emit zero carbon emissions when operating. Energy from the sun and the wind are infinite, unlike fossil fuels, we will never run out of them. More solar energy falls on the Earth in 1 hour than all the energy that our civilizations consume in 1 year. Civil engineers from the Solutions Project calculated that we could power most of the world with only renewable energy if we just actually decided to do it. If we cut back on deforestation, not only does that reduce the amount of fossil fuels burned, but there will be more plants and forests actively absorbing carbon dioxide. If we use more reusable and renewable resources, this will reduce the amount of energy needed to create new products. This will also reduce the massive amount of landfill dumping that we do. That all sounds like great, efficient, and healthy ideas, but how can I help personally right now? You can drive an electric or fuel-efficient car. Replacing your regular car with a Toyota Prius, the average person can prevent the emission of about 1 ton of carbon dioxide into the atmosphere. Now, we all can't afford to just buy new and different cars. So to help, you can walk or bike places, take public transportation, or if anything, ease off the accelerator and make your car as efficient as possible. Use energy-efficient light bulbs. LED light bulbs use only a fraction of the power of incandescent light bulbs. Air dry your clothes instead of using power-guzzling machines like dryers. Turn off electronics or lights when you're not using them. Eat less meat or no meat at all. By replacing an omnivorous diet with a vegan diet, the average person can prevent the emission of about 1.5 tons of CO2 into the atmosphere. Reduce, reuse, recycle. And of course, spread your knowledge and concerns of climate change. Remember, climate change is very real and is drastically affecting planet Earth, our home. And although we are the problem, we can also be the solution.
Let's talk about climate change. People are calling it the crisis of our time, and it is.
Climate change.
Climate change.
Climate
Changes.
Climate
change.
But it's easy to get lost in this story. The science is dense and politics get in the way. World leaders are meeting in Madrid to talk about the climate crisis and how to slow it down. And they're under pressure from millions of people around the world calling for concrete action.
The empty promises are the same, and the inaction is the same.
So what exactly are we doing wrong, and how do we fix it? We're going to kick this off with some basic science, so bear with me, because this is important. Look at this graph. These are the levels of carbon dioxide in our atmosphere over hundreds of thousands of years. But this spike in carbon dioxide at the very end, that took off during the Industrial Revolution. We started breaking CO2 records in 1950, and we haven't stopped since. Why? Well, scientists say there's a 95% chance that human activity is the cause. We've been burning more and more fossil fuels like oil and coal, which release CO2, to power our homes, factories, airplanes, and cars. There's also a lot more of us. The global population has tripled in the past 70 years. And we're consuming more products from animals that release another pollutant called methane. So all those gases are released into the air, and when sunlight gets into the Earth's atmosphere, some of the heat gets trapped, and the planet gets warmer. That's why they call it the greenhouse effect. But the concern is not that the Earth is getting warmer. It's that it's happening far too quickly.
But it's actually the warmest temperature on Earth since the last ice age, since 10,000 years ago.
The UN says that right now, our world is about 1 degree hotter than pre-industrial times. That's around the year 1800, which is okay. In fact, the UN says if we warm by 1.5 degrees before the end of the century, we should be fine. The UN even says 2 degrees would probably be all right. But again, the problem is speed, because right now we're on track to hit 1.5 degrees in only 10 years. And if we don't slow that warming down, it could mean catastrophe within my lifetime, and maybe yours too. And we're already getting a taste.
Climate change is here. Climate change is happening. We are well into the 6th mass extinction event.
Europe
is currently colder than the Arctic.
More than 1,000 people being rescued just in the early morning hours of Sunday.
Millions of people are likely to suffer worsening food and water shortages.
Drought, which is now in its 10th year, is a phenomena that's here to stay.
We've never seen a year's worth of rain in less than 7 days.
Sea levels are rising about 3 millimeters a year because seawater expands as temperatures get warmer. Melting ice sheets and glaciers also add trillions of tons of fresh water into our oceans. People around the world are already losing their homes. And if things carry on, millions more of us will have to pack up too. Entire coastal cities could be underwater within 80 years, like Miami in the US or Osaka in Japan. Entire island nations in the Pacific could completely disappear.
Natural disasters becoming more and more intense, more frequent, with more devastating consequences. The dramatic impacts of drought in different parts of the world, all this is creating a situation that is a real threat to humankind, and we are not doing enough.
If 99% of doctors said to you, take this medicine or you will get really sick and probably die, you would take it. Who wouldn't take it? The problem is, at the moment, we don't have any medicine.
Now there is a plan to slow all this down. Back in 2016, world leaders signed the so-called Paris Agreement. And the big pledge is to cap temperatures rising by 1.5 degrees or a maximum of 2 before the year 2100. So countries set their own targets on how much CO2 they emit. But here's the thing, 3 years after the agreement, global CO2 levels are still going up.
CO2 emissions have been going up the last year by 2%, so that's actually above the average of the last 10 years. So it's started to increase again, and it doesn't look too good.
In some ways, we're going backwards.
The United States will cease all implementation of the non-binding Paris Accord and the draconian financial and economic burdens the agreement imposes on our country.
The US, one of the world's biggest polluters, has pulled out of the Paris deal. Russia and China are accused of not giving themselves ambitious targets in the first place. Turkey and Poland want to build more power plants that use coal. And then there's the skeptics.
It's a political decision that there is man-made global warming.
We forced the computer models to say, human influence, CO2 and other stuff.
The ground-based temperature data has been massaged to show an increase, but the satellite data shows no increase.
On the other hand, there is positive momentum. There's more awareness, and some countries are making progress. India, Morocco, and the Gambia have massive renewable energy projects.
There are different countries doing things successfully. So some countries are, for example, making all public transport free in the cities. What a great way to encourage people out of their cars.
But experts say what's needed now is an even bigger push to change everything about the way we run our world.
Business as usual has got to change. Politics as usual has got to change. In order to combat that, we have to change the system that has allowed it to happen. You can't have infinite growth on a finite planet.
And everyone can do that by shifting to renewable energy, reducing the use of cars, use train more, cycle more, eat less meat, consume a bit more carefully.
So where does that leave us? Well, there's only so much bike riding and light bulb replacing that you and I can do every day. But the truth is that it's those everyday things that are going to change anyway. Even coffee could run out if farmers can't grow it. So the expert advice is that it's down to all of us to change our ways and shake things up, or climate change is going to do it for us.
I hope the 3 lectures you have listened give you an insightful understanding and awareness on how the climate change impacts our lives. And let's do our part, our share, because we are part of the solution in this crisis, climate change. Thank you very much. This is all for today, students. Thank you for your time. If you have questions, feel free to ask your learning facilitators at home, your parents, sisters, and brothers, or you can send an email or text to your teacher regarding your queries. For this RBI segment, thank you DepEd Dapitan City, headed by Dr. Felix Romy A. Triambolo, OIC Schools Division Superintendent, and thank you LGU Dapitan City, headed by Honorable Rosalina G. Haloshos, the City Mayor. Keep safe everyone. Bye-bye.